Welcome to my video of the 2018 Key Stage 2 Maths SATs, the Paper 1 Arithmetic paper. Now if you've just done this test, so you're in Year 6 and you've just done your SATs, this video could be useful for you. You can have a look through, and if you remember what you put for some of the answers, you can get a good idea of how you did before you actually get your results. Or failing that, if you are taking your Year 6 SATs next year or the year after, what I would suggest you do is download this paper, the link's in the description, have a go at it, and then come back and look at this video and see if you got the marks. Okay, number 1 says 39 adds 673. Now the trick with these first few questions is to do them as quickly and as accurately as possible. So we're looking for ways to save time. Now 39 is pretty much 40, so in my head I'm going to do 673 add 40, which is 713, and then minus 1, which is 712. Make sure your answer goes in the box, and that's the answer. For the second question, 9 elevenths minus 4 elevenths. Now you should know that we leave the denominator, the bottom number, we leave that alone. So 9 minus 4 is 5, and still elevenths, so the answer is 5 elevenths. And for the last one here, 2 times 45, well 2 times 40 is 80, 2 times 5 is 10, 80 add 10 is 90. Number 4, 838 divided by 1, well anything divided by 1 is itself, so it's 838. And number 5, 99 divided by 11, so how many 11s go into 99? And if you know your times tables, the answer is 9. Number 6, it says 5 times 4 times 10. What I do is I just do 2 at a time and then multiply by the last number. So 5 times 4 is 20, 20 times 10 is 200. Number 7, again we're looking for some quick answers to this. So 7064 minus 500 is what I'll do, because it's virtually that, is 6564. But we only took away 500, so we've got to take away another 2. So it's 6562. Okay, the questions are going to get slightly harder now. So number 8 is 6 squared plus 10. We need to do this first. If you think back to your bod maths, 6 squared is the same as 6 times 6. 6 times 6 equals 36. Plus 10 is 46. Number 9, I would suggest doing this as a column addition. 56.38 add 24.7. Now, in this case, they don't line up correctly because there's a gap here. Because there's a gap at the end, you can put 0 in. So 8 add nothing is 8. 3 add 7 is 10. So we put the 0, carry the 1. 6 add 4 is 10. Add the other one is 11. Put the 1, carry the 1. 5 add 2 is 7. Add the 1 is 8. So our answer is 81.08. Number 10, it says something minus 10 is 298, so you do the inverse. 298 plus 10 is 308. And just read it off just to make sure. 308 minus 10, yep, that equals 298. Number 11, 270 divided by 3. Well, we know, if you know your times tables, that 3 goes into 27. So what I'm going to do is just imagine that 0 is not there. How many 3s are in 27? It's 9. And we're going to add the 0 back on at the end, so our answer is 90. Number 12, 5,400 divided by 9. Again, it's similar to the one above. I would just get rid of the zeros and pretend that's 54. 54 divided by 9 would be 6. Now we've got to add those 2 zeros back on, so our answer is 600. Number 13 says 60 divided by 15. Now if you were to count up in 15s, 15 is the first one, 30, 45, 60, so there are 4 15s in 60. Number 14 is something equals 5,776 minus 855, and the only thing they've done here is move the equal sign from the right normally to the left. So we'll just solve that using column subtraction. 5,776 minus 855. Make sure that you line up your place value columns correctly. So we've got hundreds, tens and units. 6 take away 5 is 1. 7 take away 5 is 2. 7 minus 8 we can't do, so we'll borrow from our next door neighbour. 17 take away 8 is 9. 4 take away nothing is 4. So the answer is 4,921. Number 15 is an example of partitioning. So we've got 3,050,020. So we've got 3 million and we've got our 20. The only thing we've not got is our 50,000. So make sure that that's written correctly, and that is the answer. Okay, number 16, 10 minus 5.4. Now if we were to do 10 minus 5, we know that's obviously 5, but we have that 0.4 extra. So what we had initially was 5 as our answer, because 10 minus 5 is 5. If we were going to take away 4 more tenths from that, our answer would be 4.6. Because there are 10 tenths in a whole, we've just minused 4 tenths away from 5. So we have 4 wholes and 6 tenths left. Number 17, we're adding fractions. Now in this case we have a different denominator. So what we need to do is ensure that the denominator, our bottom number, is the same so that we can solve it. Now in order to do that, ideally we want to turn one of them into the other so that they're both the same. And in this case we can do that because this number, 5/7, has a 7 at the bottom, and this one has 21 at the bottom. Now, if you know your 7 times table, 7 times 3 makes 21. So if we multiply the whole fraction, the top and the bottom, by 3, we'll end up with 21 at the bottom. So just to set it out nicely, 5/7 times by 3. Now, technically we're not timing it by 3, so make sure to put the arrows. 5 times 3 is 15. 3 times 7 is 21. So now we have our sum that we can solve. 15 21s plus 3 21s. It's 18 21s. Number 8, 0.1 divided by 100. This is relying on your knowledge of place value. If you divide by 100, you expect the number to jump 2 spaces to the right. So at the moment we have 0.1. This is our tenths, this is our units. If we divide by 100, it's going to jump 2 spaces. So these are now hundredths, and these are thousandths. So this 1 will be here. Put that there. There'll be a 0, 0. The decimal point doesn't move, and then the 0 there. Because the 1 is the only thing that has a value, that's moved 2 spaces to the right. 0.001. Number 19 says find 3/4 of 1,000. We can find 1/4 if you do 1,000 divided by 4. You should know off the top of your head that that's 250. And then you can multiply that answer, because that's 1/4. We can multiply that by 3. So 250 multiplied by 3 is 750. Number 20, it's checking your knowledge of long multiplication. So we start with the units. 3 times 5 is 15. We put the 5, carry the 1. 3 times 8 now is 24. Add the 1 is 25. 3 times 7 is 21. Add the 2 is 23. And now we've moved on to the tens column. We've done 3 times 785. That's our answer there. Because we've moved on to the tens column, we're no longer multiplying by units. We need to put a 0 in. So 2 times 5 is 10. So I put my 0 for 10, and I carry the 1. 2 times 8 is 16. Add the 1 is 17. Carry the 1. 2 times 7 is 14. Add the 1 is 15. Now I'm going to cross those out, so I don't need those anymore. And I just got to add my answer to 3 times 785. That's this one. And this one, which is 20 times 785, I'm going to add those together. So 5 add 0 is 5. 5 add 0 is 5. 3 add 7 is 10. Put the 0, carry the 1. 5 add 2 is 7. Add the 1 is 8. 1 add nothing is 1. So our answer is 18,055. Number 21 says find 20% of 1,200. Now the trick with this, I find, is to find 10%, and then we can add 2 lots of 10% together to make the 20%. So to find 10% of something, it's very simple. You just divide by 10. Your knowledge of place value should tell you that if you divide this by 10, it's going to jump 1 space to the right. So instead of this 1 being in the thousands column, it would move into the hundreds column. So it would equal 120. So to find 20%, we just double this number. So 120 times by 2 is 240. There's your answer. Number 22 is checking your knowledge of long division. So we start with this number here. We have 43. How many times does 43 go into 6? We work our way across. 43 doesn't fit into 6, so we put a 0. So instead we say, well, how many 43s fit into 64? Well, I know that there's only going to be one 43 that fits into 64 because two 43s make 86, and that's beyond that number. So at the moment we're going to have 1. What we do now is we find the difference between 43 and 64, so we know how many spaces we've got left. Because if you imagine a bus could hold 64 people and you've only put 43 people on it, well, there'll be some seats left, and the seats left are the numbers that we carry over onto this number here. So the number we have left is 21, because 43 add 21 makes 64, so I'll put 21 in there. And then it's going to say how many 43s fit into 215. So what you can do here, if you're not 100% sure, is to put your 43 times table down and just keep adding 43 until you get to this number. And I'm hoping it'll go in perfectly. So 43 add 43 is 86. 86 add 43 is 129. Add 43 again is 172. Add 43 again is 215. Right, so we've got it. It fits perfectly. We have 1, 2, 3, 4, 5 43s in 215. So our answer is that there, which is 15. Okay, for 23 it says 0.5 times by 28, and this is just another way of saying half of something. If you times something by 0.5, it's the same as finding a half. So what you can do is just in your head is 28 divided by 2 equals 14. So our answer is 14. Okay, with 24 we have another example of adding fractions with different denominators. So what we need to do is convert one of these, or both of them in this case, to the same number. So at the moment we can't do anything to a half to turn it into fifths, because you can't express half in fifths. It would be 2.5 fifths, which we don't do in fractions. So what we could do is look at the denominator and say, well, what number could I create that's in the 2 times table and is also in the 5 times table? And a quick way of doing that is just to multiply them together. 2 times 5 equals 10. So why don't I convert both of these into tenths? So in order to create tenths with the half, we need to multiply the whole fraction by 5. So 1/2 times by 5, top and bottom, is 5 tenths. And in order to turn fifths into tenths, well, I need to multiply the top and the bottom by 2, so I get 10 on the bottom. So I'll just do the same again. 1/5 multiplied by 2, top and bottom, is 2 tenths. So now we can do the sum because of the same denominator. 5 tenths plus 2 tenths equals 7 tenths. Number 25, we have 1 3/4 plus 3/4. What you could do is change this mixed number into an improper fraction. So to do that we say, well, how many quarters go into one whole? And if you imagine a whole pizza, there are 4 quarters in one whole. So we have 4 quarters here in our whole, but we also have the 3/4 extra. So 4 quarters add 3/4 is 7 quarters. So 7 quarters is the same as 1 whole and 3/4. Now we can add them together. So 7 quarters add 3/4 equals 10 quarters. Now you could leave that as your answer, or you could simplify it down. In order to do that, we could divide the top and the bottom by 2. So that's 5 halves. And in this case, that's an improper fraction, so we could leave it as a mixed number as well. So 5 halves, or 2 wholes and 1 half, because 5 halves is the same as 2 wholes and 1 half. Number 26 says 6 minus 5.738. Now, you could go a really long and complicated way of doing this, or you could look at this number here, 5.738, and think, well, what can I add on to this to make 6? Because that's the same as 6 minus this is the same as looking at this and adding on until we get to 6. So what you could do is you could say, right, well, I've got 738 and I need to make 1,000, because when I've got 1,000, I will have 1,000 thousandths, which make one whole. We could add 200 onto the tenths column, this one here, so that would make 938, but I still need a bit more, so I would need another 62 to make 6. So I would have 0.262, because if I add that on to this number here, I get 1.000, so that's one whole, and 5 add 1 makes 6, so our answer is 0.262. Now, if that was a bit confusing for you, you could still do it, I find, a slightly more complicated way, but if this works for you, that's fine. We do column subtraction, and if you notice, we haven't got anything here, so in order to make this work, we need to put a decimal point in and put 0, 0, 0. Nothing minus 8 we can't do, so we'd look to borrow, but we can't. We'd look to borrow, but we can't, so we'd borrow 1 from here. That would be 5, that would be 9, that would be 9, that would be 1. 10 minus 8 is 2, 9 minus 3 is 6, 9 minus 7 is 2, 5 minus 5 is 0, so our answer is still 0.262. So in this example, it's 3.9 times 30. What we could do is 3.9 times by 3, and do 3 times 9 is 27, so it's the 7 carry the 2, 3 times 3 is 9, add the 2 is 11, so it's 11.7. Now, we only did 3.9 times 3, but our answer was 3.9 times 30, so that in this case we're going to have to multiply this whole answer by 10, otherwise it's not right. So 11.7 times by 10, remember if you times by 10 the numbers all jump to the left, so it'll be 117.0 or 117. 28, again we have another fraction problem, 1 whole and 1/15 minus 2/5. What we could do is start with this mixed number here and convert it to an improper fraction. So how many 15ths go into 1 whole? Well, the answer is 15. Add 1 more is 16 15ths. Now we can turn this into 15ths, this 2/5 here, which is what we need to do. They need to have the same denominator. So we could multiply the top and the bottom by 3. So 2 times 3 is 6, 5 times 3 is 15. So now we have our sum that we can do. 16 15ths minus 6 15ths is 10 15ths. And more than likely it's going to want you to cancel this down. So you could divide it by 5, which would be 2 over 3, or 2/3. Number 29 is checking your knowledge of long multiplication again. So we start with the units. 3 times 6 is 18, so we put the 8, carry the 1. 6 times 1 is 6, add the 1 is 7. 6 times 4 is 24, we put the 4 and carry the 2. 6 times 5 is 30, add the 2 is 32. Don't forget to put the 0 now, we've moved on to the 10, so 8 times 3 is 24. Put the 0, put the 4, and then carry the 2. 8 times 1 is 8, add the 2 is 10. Put the 0, carry the 1. 8 times 4 is 32, add the 1 is 33, so put the 3, carry the 3. 8 times 5 is 40, add the 3 is 43. And the last step is we add these together. 8 add nothing is 8. 7 add 4 is 11. Put the 1, carry the 1. 4 add 1 is 5. 2 add 3 is 5. 3 add 3 is 6. And 4 add nothing is 4. So our answer is 465,518. Number 30 says 99% of 200. Now what you could do, if you want to be really quick, is find 99% of 100, and you know the answer to that is 99, because 99% of the number is 99 hundredths, and if you know that in 100, 1/100th is 1, then 99 times 1 is 99. But that's not the question it's asking us. It's saying 99% of 200. So if you were to times this answer by 2, you'd get 198. Number 31, it says 1/4 divided by 2. Now the trick with this is literally just to multiply this number by the denominator. You don't need to do anything fancy or any long division or anything. 1/4 divided by 2 equals 1/8, because we've done 2 times 4. Number 32 is trying to trick you with BODMAS. So if you remember BODMAS, we remember this is the order in which we do maths. We have B for brackets, O for orders or powers, D for divide, M for multiply, A for add, and S for subtract. So we start over here and we work our way along. We haven't got any brackets, so we can skip that. We have, however, got some powers or some orders, and that's this here, 9 squared, so we do that first. 9 squared is the same as 9 times 9, which is 81. We then work our way across. Well, the next letter we can do is divide, and we have one of those. So we forget about 81 for a second, and we just do 36 divided by 9. 36 divided by 9 equals 4. So if we put these numbers back into our equation, we have 81 minus this sum here, which was 4. So 81 minus 4 is 77. Number 33, 1 and 1/2 multiplied by 40. So what you could do is you could say, well, 1 whole multiplied by 40 is 40, and a half multiplied by 40, or half of 40, equals 20. So we can just add those together. 40 add 20 equals 60. Number 34 is another percentage question. So a trick with this is to find 1% or 10% and then just keep stacking them up until we can get to 28%, and I'll show you how to do that. I would start with 1% in this case. So to find 1% of something, we divide it by 100. So 650 divided by 100, you should know, is it moves 3 spaces to the right. So if you imagine this is the hundreds column, this is the tens, this is the units. The hundreds have moved 1, 2, so it's now 6. The answer is 6.50. That equals 1%. It's always important to write stuff like this so you don't forget that this is the value of 1%. And now we probably need to find 10%. So to find 10%, we just multiply this by 10. 1% times by 10 is 10%. So 6.5 times by 10 is 65, and that's 10%. So now we can use a combination of these to find 28%. And what I would do is I'd find 30%. So I'd do 10% times 3, so that's 65 times by 3, which equals 195. And then what we can do, finally, to finish it off, is to minus 2% away from this. So 2% is obviously 2 of these, and 6.5 times by 2 equals 13. So we can do 195, that's 30%, minus 2%, or 13, which equals 182. Number 35 is another complicated fraction one. So what I would do is I would convert these mixed numbers into improper fractions. So I would say how many thirds go into 4 wholes? So it's 4 times 3, it's 12, plus the 2 thirds we've got here is 14 thirds. And I do the same for this one here. 7 times 1 is 7, plus the 6 is 13. Got 13 sevenths. Now, like I mentioned previously, we need to find a common denominator for these so that they can be subtracted together, because at the moment we can't do thirds take away sevenths. So I always say, well, what number can I create with these that's in the 3 times table and the 7 times table? You could multiply these bottom ones together. So 3 times 7 equals 21. I want to get 21s at the bottom again. So in order to get 21s on this fraction, I need to multiply the top and the bottom by 7. So 7 14s are 98. I did 7 times 10 and then 7 times 4 and added them together, over 21. Minus, now we need to multiply this by 3 to get 21. So we've got 39 21s. So 98 minus 39 is 59 21s. And all we need to do now is simplify this. How many 21s go into 59? Well, let's do the times table. 21, 42, 63. That's too much. So we know that we can have 2 wholes in there, up to 42, and then whatever's left, which is 17 21s. So that is our answer. Well done if you've made it this far. You're on to the last question. So it's just checking your knowledge of long division. How many 97s go into 8 is 0. How many 97s go into 88 is also 0. So how many 97s go into 882? And again, what I recommend is just putting the 97s down here and trying to add 97 every time. 97 and 97 is 194. Add another 97. You could do 100, so that's 294 minus 3, which is 291. And we can keep going. Add another 97, which is 388, 485, 582, 679, 776, and 873. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 97ths in 882. And what we've got left is 9. So 9 goes in there, and obviously how many 97s are in 97 is 1. So our answer is 91. Thank you for watching this video. I hope you found it helpful. Please like the video if you did find it helpful, and subscribe to my channel for more helpful videos. Thanks for watching.